What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we are going to look at part 8 of our Pandas tutorial series in Python. So, to kickstart this video, guys, what we will be looking at is basically the concept of arithmetic. So, let me type this here as a comment. Arithmetic and data alignment. Okay, and we are talking about this, you guys know, in with respect to the series object as well as the data frame object. So you see, just to give you a bit of insight, right, we have been working with the concept of indexes all this while. Okay, we have seen how powerful the indexer row and the header column can be when it comes to having the ability to query the data frame or the series object that you are working with. Now you see, just to give you a bit of insight, right? When we are adding two objects, suppose we have these two series objects, okay? And we are adding the series 1 object with series 2. Now, what's good to understand before we actually look at the practical example, I'm just, giving you guys some sort of theoretical explanation. Now, you see, when we take series 1 and add it to series 2, and if any index, any index pairs between both of them are not the same, then the output or the resultant series is going to be basically, it's going to be a union. Okay, it's going to be a union of series 1 and series 2. What I'm saying is, by default, when you attempt to, add two series together, and if there are certain index values that are not common, across both, what you'll find is that really it's just going to be the resultant series will be a union of both series objects. Okay, so that's a simple theoretical explanation. Now I'd like to show you guys exactly how this works. So go ahead, guys, import pandas as pd. Let's set up series 1. So pd.series. We'll keep this simple. Let's do 7.3. Let's do negative 2.5, 3.4, and 1.5. For the index values, let's do index is equals to, and I will pass indices here. So let's do A. I'd like to do C, D, and E. Okay, so that's what we have for series 1. Now let's do series 2. pd.series. Within this, let's do negative 2.1. Let's do 3.6, negative 1.5. Let's do 4, and let's do 3.1. Okay, so that's what we have here. There are 5 values in the second series and 4 values in the first series. So index is equals to, in a list, let's pass the indices. Let's do A, C, E, F, and G. Okay, so what you guys are going to notice is that there are certain index values that overlap or basically are common across both the series objects that we have. A is found in both, C is found in both, E is found in both. D is unique to the first series, F and G are unique to the second series. Now, just to give you guys insight, you can view these objects if you'd like to. This is series 1, and let me print series 2. That is series 2. So what are we attempting to do now? Now we are attempting to perform arithmetic on the series. Let's do a simple, addition operation. S1 plus S2. Now think about it. We are basically taking this series with 4 values and we adding it to the series with 5 values. Now, there are certain index values that are common across both. Now, you guys know when we covered the concept of series, we learned that series have automatic index alignment, or as they call it, data alignment. This tells us that now when we adding the output, we can expect to see, you see, A is found in series 1 and so is it found in series 2. So A will be set to be equal to 7.3 plus negative 2.1. That will give us a value of 5.2. Now, On to C. C is negative 2.5. C is also found in the second series. So it will be added negative 2.5 plus 3.6. That will equate to 1.1. Now D. D is only found in series 1. It has a value of 3.4. Now, what's going to happen when series 2, right, is attempted to being added to series 1 for the index D? There is no D in index 2. So basically that D, index D from series 2, will be set to a value of NaN. Okay, and I should mention this now before we even run the code, that NaN is a non-existent. It is missing, it is null. Okay, and anytime you have NaN involved in any operation, the output of that operation will be NaN. Guys, please pay careful attention to this line, okay? NaN, it's a missing, it's a null, it's a non-existent value. Any operation in which you have an NaN, irrespective of what arithmetic operation it is, if there's an NaN that is involved or included in the operation, automatically the output of that operation is going to be set to a value of NaN. Okay, so in the instance here, as our example, D is basically going to be such where 3.4 plus, there's no D in the second one, so therefore plus NaN, and the output in the resultant series will have an index D, but the value for that index D will be NaN. That's a simple theoretical example I gave you. I am going to run this now and you guys are going to see exactly what I mean. Okay, D, despite being in series 1, it is not in series 2. Therefore, when being added to series 2, the value from the first series gets added to an NaN value, a non-existent value, and therefore in the resultant series that we see here, D indeed has a NaN value. Okay, F and G follow the same logic. It is found in one, it's not found in the other, and that accounts for the NaN that we see there. That is simple addition arithmetic on a series object. Now, I will demonstrate for you guys just a few of the other arithmetics that you can do because it is really simple. Majority of the arithmetics that can be performed in standard Python it can be performed on our series objects, right? Because remember, these are NumPy arrays and they will support broadcasting. That is why we have the ability to perform such arithmetic on them. Okay, so yeah, there we have a subtraction operation there, and yeah, you guys can experiment with that, go crazy, just multiply, divide, floor divide and so on, just to see what you obtain. Okay, so I will conclude the arithmetic portion there. Now, we did this for series. You may ask, what's the operations like? What's the technique or procedures like when we perform arithmetic on a data frame, right? How does data alignment, as we see up here, how does arithmetic and data alignment work when applied to a data frame object? So let me show you guys a simple example. Go ahead, import pandas as PD. We will create our data frame 1. So I'll call this df1 just to save some typing time. So data frame, okay, df1 is equals to pd.dataframe. I would like you guys to import numpy as well. We'll use numpy to generate the dummy data for us. So numpy.arange, this will be set to 9. Then we can reshape this to have a shape of 3 by 3. So we have a little tabular like structure. I'll set the columns to be equals to the list of B, C, and D. Next, I'd like to do the index. Let's set the indices to be Ohio. Let's do Texas. And last but not least, Colorado. Okay, that is data frame 1. So I see I have an error here. This error, okay, it was just temporary. That's fine. Data frame 2 is equals to PD. This is a new object, guys. Data frame 2 PD dot data frame. Let's do numpy dot a range, and within this we'll make it a 12. And what we can do is reshape this now to have a shape that is 4 by 3. One more level of brackets, so that's there. That is fine. Now columns, let's do columns. So columns is equals to, let's do a list, and within this we'll pass BDE. So last but not least, index is equals to, now let's do a few different indices than we have in the first data frame, because the whole point of this is to see and assess how data alignment works. So when we are attempting to operate on two objects which are series or data frames and they have differing index columns, how does it work? How do they get solved, and what is the resultant of the operations? Okay, so for this, let's do Utah, let's do Ohio, I'd like to do Texas. So Texas is one of the common ones across both objects, and now we can do Oregon. Okay, now that's the two data frame objects we have. If you guys would like to view the objects, you may go ahead and do so. The first one is a small 3 by 3, and we have the second one, second data frame object, which is a slightly bigger 4 by 3. Okay, now you guys know, just to reiterate, when we have or when we are working with data frames, basically it is rows then columns. Okay, so 4 by 3 says 4 rows but 3 columns, and that is as we see here. Now this list syntax you see here, that is standard Python. You guys know that that's the default way in which this combination of strings and the list constructor method works. Okay, so it does indeed split them up for us. Anyway, what we are focused on is the indexer column. We have Ohio, Texas, Colorado. We have Utah. That's the odd one out there. So Ohio is also in the first one. Texas is also, but Oregon is not. Even Colorado can be seen to be the odd one out, because data frame 1 has it, but data frame 2 does not have it. So let us now experiment with some arithmetic. So first things first, let's do a simple addition operation, df1 plus df2. I'm going to run this, and as you guys see, this is what we obtain. What's important to pay attention here, right, is data frames, they do not only work across one axis, they work across two, that is row and column. Okay, pay attention. We discussed the indexer column. That's fine. What we did not, and what I am talking about now, I saved this for us to specifically isolate and talk about, is the fact that data frames are 2D. Pay careful attention when you are working with a series and when you are working with a data frame. See, these data frames that we are working with here, we need to see how they match up across two axes, the row and the column. So B is found in both, D is found in both, but C and E are not common. This tells us now that the resultant, this is the resultant data frame. How many how many rows basically will the resultant data frame have? The number of rows it will have is the number of unique indices that exist in the, objects that were used in the arithmetic operation. So Ohio is one unique row, Texas is another, Colorado is number 3, Utah is number 4. We're not going to count Ohio because we counted it in the first one. We're not going to count Texas, and we will count Oregon, so that's number 5. And as you see, there are 5 rows here. How many columns will the resultant data frame have? It's the exact same rule. Count each column basically one time. Okay, each unique column should be counted one time. So B, that's 1, C, that's 2, D, that's 3. B and D have been counted before, so E, that's 4. So 4 columns, and that is what we observe. And now what we are going to basically see is that in those cells, let's call it cells, in those cells where the two data frames that we added did not match up, what you will see is that it has been populated with an NaN value. So let's do a simple example here. Take Colorado, for instance. Colorado, as we see in the resultant data frame, it has NaNs for all values in the row. Now you may ask, but you see Colorado has 3 values here, so why is it that, the resultant data frame has the entire row showing with nulls or NaNs? Now, guys, the explanation is the same for series, right? Colorado is present in data frame 1, but is Colorado present in data frame 2? The answer is no. That is why each cell for Colorado is attempting or being attempted to be added to each cell in Colorado in data frame 2, but Colorado is a non-existent row here, and that is why you are basically adding NaNs to each column or each cell, and that accounts for what we see here. So that was kind of a lengthy explanation, but I hope that makes sense to you guys. Now, just to reiterate this point as well, that series and data frames, logically speaking, there's not much difference between them. So you'll have the ability to do various types of arithmetic on your data frame. So I will leave that for you to explore. One more thing that I'd like to actually demonstrate for you is, let me show you, right, what happens if you add a data frame object with no column or row labels in common. Okay, so let me comment this here. What happens if we add or let's say 2 data frame objects that have no row labels or columns in common? Okay, so instead of saying what happens, let's say this is what happens, right? Since we will be doing that now. So let us see what happens. Go ahead guys, import pandas as PD. Create our data frame objects. Let's do df1 is equals to pd.dataframe. Don't stress guys, I won't tire you out. These are small data frames that we will be creating. I just want to show you guys what happens when we attempt to add 2 data frames that have no rows or columns in common. Okay, so let's do 2 values, 1, 2. Now data frame 2 is equals to pd.dataframe. Within here a dictionary, I shall say B. That's going to be the name of the column for this data frame, and the values themselves can be 3 and 4. Now let's print data frame 1. This is what data frame 1 looks like. We have the indices 0 and 1 automatically assigned by Python, and we have the data points or values 1 and 2. The column is A. Now df2, we have 0, 1. We have values 3 and 4. We have B as the name of the column. Now let me go ahead, data frame 1 plus data frame 2, and now when I run this, you guys are going to see what happens. Okay, so control enter, and as you guys are going to see, we obtain this. Now you may ask why. Now the explanation for this is easy guys. It is because the answer lies in this comment, because we are attempting to add 2 data frame objects that have no row labels or columns in common. Right? Now you may tell yourself 0 and 1 is common across both these data frames, but think about it guys, these are the implicit Those are implicit index values. Implicit. Python by default just starts at 0. For the second data frame, what's there stopping Python, from starting at 1001 and 1002? Okay, so logically speaking, these data frames that we are adding, they have nothing in common. No index or rows in common. My bad, no indexes or columns, right, in common. That accounts for what we see here. So let me walk you through the logic. I don't want you guys getting confused. So let's take this first row. Now this first row is attempted to being added to the first row of B. But now there is nothing common between these data frames themselves. There's nothing common at all. And that is why basically what we are doing is, since we are adding the first data frame by the second, we are saying basically 1 plus NaN, and that gives us NaN here. We are doing 2 plus 4, and that gives us NaN here. So I hope that makes sense to you guys. Now, basically, that is all that I'd like to show you with regards to arithmetic on data frames. There is more operations that I'd like to talk about, but with regards to the indexes and columns, this is about it. All right. Okay, guys, so before we actually conclude the topic of arithmetic, right, while we are discussing it, I'd like to show you guys one more interesting feature. It is likely something that you will use, especially if you deal with data and data frames in your daily tasks. So, you see, it is basically using arithmetic methods to fill values in the, so I spelled values wrong, in the data frame. Arithmetic methods that are used to fill values in the data frame. You guys know NaN is basically null, missing, or non-existent. You guys can call it whatever you want, but the point is there's no value there. There's no value there. Now, it is for this reason why sometimes, depending on the data you're working with, maybe you'd like to fill the NaNs with a certain value just so you have some sort of data that is there when you are attempting to process the data itself. Now, let me show you how you have the ability to actually fill the NaN values with a value of your choice. So import pandas as PD. We'll have data frame 1 is equals to PD. So import numpy as well, guys. Okay, that's what we have there. Data frame 1 is equals to pd dot data frame numpy dot a range. We'll do 12 and we'll reshape this to have a shape of 3 by 4. Next, what I'd like to do is I would like to set my columns to be equal to the list of A, B, C, and D. That's data frame 1. It's a 3 by 4. 3 rows, 4 columns. Now data frame 2, pd.data frame. Within this numpy.a range, we'll do 20. We'll do dot reshape. And within parenthesis, let us pass the shape of 4 by 5. Last but not least, columns is equals to list. And we'll provide the 5 columns, which is A, B, C, D, and E. Now, here comes the fun part. So first things first, view the data frames, guys, see what they look like, and then we will attempt to work on these data frames. Now, I want you guys to see, this is us using the lock method or the lock indexer method, data frame 2 dot lock, and we'll use 1 and B. And we'll set that equal to numpy dot nan. Okay, now pay attention to this. This is something we covered in the previous video as well. Data frame 2 dot lock. It tells us that we are attempting to index the data frame 2 using the lock method, which is basically the explicit indices. Okay, now in our case, we want row 1, column B. Where is that? This is data frame 2, the larger data frame. So row 1, this is 0, that is 1, and column B, which means the 6. We are setting that 6 to a value of NaN. So cell 1B should have an NaN when I run this code now. And it is as we see, there's cell 1B here, okay? Now there is an NaN there, so that's fine. Now, what I'd like to do is show you what happens when we add the two data frames together. So there is only one NaN in data frame 2. There's no NaNs in data frame 1. But one thing that you will see is that the columns themselves, there's a few columns or column that's not common between both. Okay, that is column E. So let me go ahead and show you data frame 1 plus data frame 2, control enter, and this is what we obtain. Okay, now the reason for this is simple. It is because you see one data frame has 3 rows, another has 4 rows, one data frame has 4 columns and the other has 5 columns. This accounts for the resultant data frame that we see, which has a 4 by 5 shape. Okay, so I hope that makes sense to you. Now, what I'd like to show you, you guys see that there are NaNs here. The focus of this cell of code is not showing you the addition. It is to show you how to fill the NaN. So you guys see, now we have NaNs in this data frame. We don't want the NaNs to be in the data frame. And we don't want to delete the rows or columns that have NaNs. Instead, we want to fill the NaNs with a certain value. Okay, so let me show you how we do this. I will start a new line here. What I'd like to do now is print. So let me comment this. Print data frame 1 dot add. Now I should mention to you, right, that you basically have the ability to add and subtract using these built-in pandas methods. Okay, so data frame 1 dot add will allow us to add a data frame to the object that we call it on. So basically, if I want to do add data frame 1 and data frame 2, instead of using the plus sign, I can do df1 dot add, and within the parenthesis I'll pass df2. The output will be exactly the same. This is something I'm showing you guys out of the blue, just for preference method. Choose how you would like to add the objects according to your preferences. Okay, that's fine. Now within this, the reason as to why I am using this add function is because it is convenient. Why? Because there's another parameter here called fill value, and by default this is basically set to a none value. So it's not filling the NaNs in the data frame with anything by default, right? It just lets the NaNs be. Now what we can do is set fill value to any value that we want, and effectively that's the value that will show up in the data frame instead of the NaNs. So you have the ability to pass any value that you'd like to fill the data frame with for the fill value parameter. Now I should mention, right, the order of the operations is such where first the data frame that is to be added gets filled with values, then the arithmetic operation takes place. Okay, so that's something I should mention to you. So basically, you guys know data frame 2 is the one that has the NaN. Now what's going to happen is basically it's going to get this data frame with the NaN will get filled with the fill value, and then the first data frame will get added to it. Okay, so when I run this, you guys are going to see that we obtain some output. So suppose we'd like to set the fill value to a value of 22. So I do control enter, and this is what we see. Now that is really very interesting stuff. Now I should mention to you as well, right, with regards to the concept of adding. So I'll pull up data frame 1 as well. Now you see data frame 1 had a value of 5, and this is how we know the order of in which the operations take place, because the resultant array or data frame shows 27 for 1b, and here the data frame 1 has 5 for 1b. Okay, so first the second data frame where there was a NaN, it got populated with 22, and thereafter the fill took place, or rather the addition operation. So first the fill value and then the addition operation took place. That accounts for the 27 that we see there. So I hope that makes sense to you. Now, I mean the possibilities and options you have to actually perform arithmetic on your data frames are endless, guys. Division will work, you know, multiplication, exponential, minus, plus, floor division, you know, a whole lot of other stuff will work for you. Okay, now what I'd like to show you is that you guys should know this important concept or feature of pandas itself. Let me show you. So print data frame 1. This is data frame 1. Okay, data frame 1 is the smaller data frame that we have been working with, the 3 by 4. Now pay attention to this data frame. What I'd like to do now is a simple operation. I am taking 1 and I'm dividing by data frame 1. So basically every value here from 0 to 11 is going to get divided by 1. 1 divided by the specific number. So 1 divided by 0, 1 divided by 1, 1 divided by 2, 3, and so on and so forth. Now pay careful attention to this, guys. So basically in those mathematics situations, a result of infinity can be obtained. Okay, that's just something I wanted to show you guys, that it is possible with pandas. Now that is good. What I'd like to show you for the next portion of this video, so this video is clocking about 35 minutes or so far, but it's fine, we are having an interesting session. What I'd like to show you is, you may ask or you may wonder, right, is it possible to do or perform operations between series and data frames? Okay, now the question to that is, it is possible. You can. Okay, now let me show you how you can do this. So let me give you a small demonstration. I'll create a new cell, import pandas as pd, import numpy as np. I will create a frame or data frame, pd.data frame. Let's do numpy.arange 12.reshape 4 by 3. Next, I'd like to do columns is equals to list and BDE, or let's do DBE. Now, index is equals to, and we'll set it to a list here. Let's do Utah, Ohio, Texas, and last but not least, let's do Oregon. So Oregon. That's the data frame we have. Go ahead, view this data frame. This is what we have. Now I want to create a series, but I'm keeping things simple. I will create the series from the current or existing data frame. How I can do this is basically data frame dot iloc 0. Okay, data frame dot iloc 0. That is basically the Utah row. Row 0 is Utah. So that in itself is a series. Now print series. Let's comment the data frame 1 out. This is what we have. We were expecting that. Okay. Now let me show you what happens, or how you can perform arithmetic on a data frame and a series. This is the data frame we are working with. This is the series we are working with. Now let us go ahead. Let's do data frame minus series. When I subtract this, this is obvious, right? You see, Utah is common across the series and the data frame. So we have three values in the data frame for Utah, and so do we have three values in the series for Utah. So this operation is not something that will be mind-blowing because Utah will just show all zeros. Okay, you're taking the data frame's values and you're subtracting the series values from it. Okay, so that's why all zeros display for us over there. Now, you may wonder, what if the index value is not found in the data frame's columns or the series index? Okay, what I'm saying is, what if they have different indexer columns or header rows? Okay, so let me show you. The operation is the same. I mentioned this before. It will basically be a union of the two objects. Okay, so that's just a spoiler for you. Series 2 is equals to pd dot series. Let's do range 3. Index is equals to b e f. Okay, so you'll notice that we are giving some different index values for this series object. We have BEF. The data frame we are working with has D, B, and E. Okay, so F is the odd one out, as well as, so let's see, D. Yes, D and F are the odd ones out. So print data frame. Let's do a plus series 2, and you guys are going to see this is exactly what we expect, because column D and column F are the ones that are not, common across both the objects we are attempting to add. So that's fine. Now, that is all that I'd like to show you for this video. We have covered quite a bit of interesting concepts in this video, still pertaining to the Pandas package and the concept of indices when working with series and data frame objects in Python. So thanks so much for watching, guys. Thanks for your time. Good luck with your work, and I will see you in the next YouTube video.